Okay, functions and data analysis fans, our topic for today is section 2-2, standard deviation and the normal distribution curve. And before we start, let me tell you your joke of the day. What time did the woman go to the dentist? And the answer is 2:30. Tooth hurty, tooth hurts. Okay, that was terrible. So talking about standard deviation, normal distribution, we're going to have a few vocabulary words that we're going to be using quite a bit. And the first one is the mean, and another word for mean is the average of a set of numbers. Average of a set of numbers. And remember that the mean is basically you add up your numbers. It's the sum of the numbers divided by the total number of numbers. And I'm going to use the number sign, number of numbers. So you add up all of your data and you divide by the number of pieces of data. Now we're going to introduce a symbol here for the mean, and it looks like this. It's the Greek letter mu. It kind of looks like an M or a cursive U shape right there, but that's what we're going to use for the mean. Standard deviation, the symbol for that is a circle with a little line coming off it, almost like a tail. What standard deviation represents, it is a measure of how spread out your numbers are. A measure of how spread out numbers are. And then what the z-score represents, and we'll use just the letter z for that, what the z-score represents is how far a data point is above or below the mean. Is above or below the mean. Another way to think about it, it's the number of standard deviations. Okay, I'll use the symbol. The number of standard deviations from the mean. How far are you from the mean? Are you above it? Are you below it? And by how much? Now what happens here, what you see down here, this curve is called a normal distribution curve. In the past we would have called this a bell curve. And in the middle, so you'll notice it kind of rises up like a bell, and it kind of hits its top, and then it comes back down. In the middle, you are used to thinking of the middle as what we call the median. Now, a standard normal distribution curve, you could use this for, say, the population. If you're talking about the heights of people or the weights of people in the United States, it would take the shape of this kind of curve right here. Most people would be around the middle section. Okay, so the highest point of the curve is where the most data is where the most numbers are. Notice that if you go far out to the right or far out to the left, there's not much space underneath the curve. So there are very few values that would be down here. And there are very few values that would be up here. The number in the middle, you see this 0 here. This is actually the mean. That's the average. If it's a standard normal distribution curve, the mean and the median are actually the same. The middle number is going to also be the average. And that doesn't happen with other sets of data. It's only if it's a standard normal distribution curve. Now, the numbers 1, 2, and 3 represent the standard deviations above the mean. And the negative numbers represent the standard deviations below the mean. The z-score, for one standard deviation, the z-score is equal to 1. 2 standard deviations, the z-score is 2. Here the z-score is 3. -1 standard deviation, the z-score is -1. And -2 and -3. Let's say this curve represented the heights of all adults in the U.S. If you are above the mean, if you are above average, what that means is that your standard deviation, your z-score, is positive. So if you're to the right, that means you are taller. If you're below the mean, if you have a negative z-score, that means that you are a little bit shorter than the average. One thing to understand is that when we say below average or above average, it doesn't mean good or bad. It just means where you are or where the data is compared to the other values. Okay? Now something happens here with a standard normal distribution curve that we know for a fact that from -1 standard deviation to +1 standard deviation, and I'm going to come up here, we're going to draw this above. So from -1 to +1 standard deviation, and we'll talk about this, we'll say within 1 standard deviation is 68.2% of your data. We know for a fact in a normal distribution that 68% of your values will be between -1 and +1 standard deviation. That is always going to be true. Now if you go out to 2 standard deviations to the left and to the right, okay, we'll come up here and connect it. Within 2 standard deviations is going to be 95.4% of your data. If we're talking about height, 95% of the population is between -2 and +2 standard deviations in this area here. 68% of the population is between -1 and +1 standard deviation. So most people's heights are going to be pretty close to the average. A little bit above, a little bit below. All right, now from -3 standard deviations to +3 standard deviations, so within 3 standard deviations, I'm kind of running out of space here, within 3 standard deviations is going to be 99.6% of your data. So basically everybody is going to be between here and here. Everybody will be contained under here. Now we can also break this down. You'll notice I kind of drew some sections. If this is 68% of the data, if I divide that in half, 34.1% would be this section here, 34.1% would be this section here. So it's going to be the same number to the left and to the right. From -2 to -1, standard deviation is 13.6%. And then from 1 to 2 is also 13.6%. And then from 2 to 3 is only 2.1%, and then the same thing here. So what you notice is that as the curve gets lower, you have fewer and fewer people or data values that are going to be underneath the curve. And way out at the ends, so you might think, hey, is this 100% of people? No, it's not. Past 3 standard deviations is about 0.1% of the population. Very small. And then way off to the left here is also 0.1% of the population. So if we're talking about height, there are a few people that would be way, way, way at this end of the spectrum. They'd be very tall. And you have a few people that would be very short. All right, now we can figure out using the tables here, example number 1, using the tables, what percent of a data set has a z-score less than 1? Well, we have this table of values of z-scores. And you'll notice there are a lot of numbers here, a lot of numbers. And what the z-score tells you, we can use this table to figure out the percent of numbers that are to the left of that value. Now, if your z-score is negative, so the mean is in the middle, right here. If the z-score is negative, you're going to have less than 50% of the population is going to be to the left of this value right here. If your z-score is positive, you're going to have higher than 50% of the population that would be less than, that would have a smaller value. So as I look at this table, On this page, these are negative z-scores, negative 3.4, negative 3.3. And reading across here, 0.00, 0.01, we usually round to the hundredths place. Okay, and I'm going to show you this in a second. This is kind of confusing here. Notice that if your z-score is at negative 3.00, only 0.0013, that would be 0.13%, 0.13%, very small amount of population would be to the left of that z-score. Now what they're asking us in the problem here, what if the z-score is less than 1? What percent of data would be less than that? So what I'm going to do is I'm going to flip the page over to where my z-scores are positive, and I'm going to go to 1.0. So when the z-score is 1.0, now notice the first decimal here is 0.8413. 1.0, and let's say the hundredths place was 0. So this would be a z-score of 1.00. This is the probability that a data point would be to the left of that z-score. If this is 1.00, then 0.8413, or 84%, would be to the left. Okay, so what percent of a data set has a z-score less than 1? It would be 0.8413, which is 84.13%. So if we're talking heights, if your z-score is positive 1, that means that 84% of people would be to the left of that height. 84% of people would be shorter. Okay? So if the z-score is greater than or equal to 1, so if the z-score is greater than or equal to 1, well, that would be everybody else. So if 84% of the population is to the left, what would be to the right? What percent of people would be taller than that? Well, it has to add up to 100%. Now 100% is also equal to the number 1 as a decimal. It's 1.00. So if 0.8413 is less than that z-score, if I subtract that, then I get the probability that a value is greater than or equal to that z-score. So that would be 0.1587, which is 15.87%. And if you add these up, they add up to 100%. Okay, so that would be everybody. If the z-score is less than negative 0.84, so what we'll do is we're going to take our chart and we're going to go to z, the column here, negative 0.8. All right, that's here, but I want negative 0.84. Now as I read across, okay, I know it's hard to see, I'm going to come up to the top. This would be the hundredths place as 1, 2, 3, 4. So what I'm going to do is go down this column, and I'm going to go to negative 0.8. If I come across negative 0.8, 4. And notice that where they meet here is 0.2005. So the probability that a z-score would be less than negative 0.84 is 0.2005, which would be 20.05%. Now how about having the z-score greater than or equal to that? Well, that would be everybody else. So that would be 1 minus 0.2005, which is 0.7995, or 79.95%. Okay, now the last thing here, let's say we have 180 values in a set that is normally distributed. So that means it would look like this curve right here. Everybody would be under the curve. How many can be expected to be less than z equals 1.5? So z equals 1.5. Well, let's first find the percentage. So I'm going to go to z equals 1.5, and we'll assume it's 1.50. So 1.5, here's the 1.5 row, and here's the 0.15. This is where the hundredths digit is the 0. Let me come down. And where they meet is right here at 0.9332. 0.9332. So when z equals 1.5, that leads to a probability, a decimal, 0.9332, which is 93.32%. 93.32% of the population would have a z-score to the left of that. Okay, so if we had, let's say there are a total of 180 values, 93% of those values will be less than, will have a z-score less than this. So I want to take 93.32% of 180. Well, when you take a percentage of a number, what you do is you multiply. So 0.9332 times 180, and this will be a calculator problem here. So we'll take 0.9332 times 180, and we get 167.976. So 167.976. So what that means, approximately 167 values would have a z-score that would be less than 1.5. So if your z-score was this, you'd be right at the top end. You'd be in the 93rd percentile. Most of your data values would be less than this. Now, in this case, if you wanted to round down, it's approximately 167. We would round down because if you are this person, then you can't have 0.9 people. So if you were here, 167 people would be to the left of your value. And that's the end of part 1.